Assalamualaikum and a very good day. My name is Syahira Amir and my Matric ID is A17CS0271. In this video, I will explain to you how to perform genetic algorithm using Matlab optimization tool. So before I start recording, I already run my Matlab because my laptop cannot handle recording the video and also running the Matlab at the same time. So I decide to run the Matlab first and record it. So to start off, first we need to create a live script, and I have created a live script here, and for Matlab live script is .mlx. Next, we need to define the variables that we are going to use in this problem. So first, I define the number of variables. Here, I define it as numVar, which is equal to 2 because I have two variables, x1 and x2. And after that, we need to define our lower and also upper boundary. So the lower boundary here is set to two values. The first one is for the first variable x1 and the second one is for the second variable, which is x2. And same goes with upper boundary. I set it as ub, and the first value is the upper boundary for x1 and the second is the upper boundary for x2. After define the variable, you need to run it, and the value of this variable will be saved in the workspace here at the left corner bottom here. And after that, we can go to tasks here at the above of the header, and you can click on it, and there's a lot of tasks that you can choose here. However, for this problem, we will use optimization task called optimize. After you click this, the optimized task will appear on your live script here, as you can see here. And here you can do a lot of you can set a lot of settings that suits with your problem. So first, in order to do genetic algorithm, first we need to choose non-linear objective, and then since we have boundary, so we will choose our constraints as lower bounds and upper bounds. And then we can choose our solver. There are a lot of solvers that you can choose, and one of it is genetic algorithm. As you can see here, there are a lot of other options that you can choose apart from genetic algorithm. But since we are going to solve this problem using genetic algorithm, so we're going to select genetic algorithm as our solver. So when we select the solver, the select problem data will change according to our solver. So for genetic algorithm, there is objective function, number of variables, and also constraints. So we can create our objective function by choosing local function here. And you can also select from file if you already have the objective function that you have created before. And then here there will be a list of objective function that you have created. If you haven't created one, you can simply click new button, and then there'll appear objective function code here, a predefined one. However, you can change this code based on your problem, and I've changed it based on my equations. Here is the equations that I will use for this problem, and this is my variable x1 and x2. And then I can choose my number of variable. I select it from the workspace that I have created just now, which is numVar. And also the constraint, I can also select from the workspace that I've set the name as LB and UB for lower bounds and upper bound respectively. And then for specified solver options, for genetic algorithm, there are a lot of settings that you can do, such as algorithm settings, diagnostics, population settings, runtime limits, and also tolerances. These are the settings that I have set: the crossover fraction, the mutation function, the selection function, and also the population size. So here I set my crossover fraction as 0.5. The default is 0.8. However, you can choose any number that you want to experiment with. And this is the mutation function. I use mutation uniform, where the default rate of mutation is 0.1, but you can change it as well to 0.2 or 0.8. You can change it at the code. And then this is the selection function. Selection function I use is selection roulette wheel, and this is the population size, which is 40. Since we have 20 data, which is from the 1st May until 20 May, so I double the population size, because the bigger the population size, the better the result will come out. So and as you can see, based on the solver options here, in each generation, 2 parent chromosomes are selected based on their fitness values. Since we are using roulette wheel selection, so the fitter the parents, the greater the chance for them to be selected. And these chromosomes then are used by mutation and also crossover operator to produce 2 offspring chromosomes for the new population. The population size that I said is normally bigger than the size of the individual that we have. So as I mentioned just now, the population will be doubled from the number of data, which is from 20 to 40. And here you can also display the progress. You can choose what to display, like the final output or the result of each iteration or the diagnose. And this task optimization, you can do visualization by choosing the scores, best individual, best fitness, or you can view any other visualization that you want, such as the selection, the stopping criteria, or the range, or even the expectation value. And below here, you can show the code, and it will show the code that has been created for you based on the selection that you have, based on the setting that you have made just now. So after running the code, here is the result that I got. And since I choose to visualize the scores, best individual and the best fitness, so that is what I can visualize here, as you can see. And then the optimal point of x1 and x2, you can find it by using this code here, solution and also objective value. By using the command window below here, you can simply type solution, and it will give you the optimum points for x1 and x2. So based on the result below here, the optimum value for x1 is 5808.3, and the optimum point for x2 here is 8566.5. And then you can find the minimum value of number of cases, which is our y here, by using the objective value. So you can command the objective value, and it will give you the minimum value of number of cases, which is 3356.7. So in conclusion, genetic algorithm is a stochastic algorithm, and the results produced every time we run the algorithm will always change. It never be the same. The parameters such as selection, crossover, and mutation play important roles in optimizing the gene selection process. That's all from me. Thank you.